Let us understand how do we find displacement and distance traveled from the velocity function. It is integration, of course. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are taking up applications of integration. Now here is a very important question based on motion of a particle. We'll relate velocity over displacement and distance. The question here is, an object moving along a horizontal straight line relative to a fixed point O has velocity function Vt equals to t square minus t minus 2 centimeters per second, where t is between 0 to 4. Question 1a. Draw a sign diagram for velocity for t equals to 0 to 4. Determine displacement function st. Write its unit. Evaluate displacement at t equals to 0, 1, 2, and 3. Determine total distance traveled in the first 3 seconds. So that's a standard question which is normally asked in any test paper on this particular topic. Now if you understand, we have a displacement and we also have distance traveled. Now distance traveled is a scalar quantity, so you have to add the positive values. You get the idea. Displacement is a vector quantity, so you have to add as such, and that makes a huge difference. Let us see how do we solve this question and answer. You can always pause the video, answer the question, and in case you need help and want to learn directly from me, you can always send an email on the address given. Perfect. So let's begin with the very first part. Now, this is an important step while solving. We are given an object with the velocity function. Let's rewrite this function, which is v of t is equal to t square minus t minus 2. Now, it can be factored easily. Product of minus 2 sum of minus 1 means t minus 2 times t plus 1. So that becomes the velocity function in factored form. Sign diagram. So for sign diagram, we can see where the zeros are and then make the sign diagram. So we can see the zeros. Zeros are at t equals to 2 and at t equals to minus 1, correct? So based on this information, let's make the sign diagram. Sign diagram really means that in the given interval, whether the velocity is positive or negative, right? So we are looking for positive / negative intervals. That is the meaning of sign diagram. Clear? Okay, so let's make a table here. Now, we are given the domain of the function as t is from 0 to 4, right? So that's the domain, right? So I'm just, there's no need to highlight like this. But within this interval, we have to consider the function. We have t equals to minus 1, as you can see here, but this is outside the domain here, right? Somewhere here. So we'll keep it there, but remember, when you take a test point, you should take it on the interval which is mentioned. So here we have, I'll just write t equals to minus 1 here as one of our points. Make it a whole, right? Not included. Well, the whole interval is not included before 0. But the important other point is t equals to 2. So we'll consider on either side of t equals to 2, right? So let's take a test point. So we'll take a test point in the interval from 0 to 2. So we have this interval from 0 to 2. And then we have from 2 to 4, correct? Any test point can work. So let's take 1 here and 3 there, correct? So these are the test points for our function. We know it is 0 at 2. Since it is a parabola, polynomial, a continuous graph, on either side it could be either positive or negative. Perfect. So if I substitute 1 in this particular equation, then what do I get? Well, we can do factor by factor. So we have t minus 2 as one factor and t plus 1 as the other factor. If I substitute 1 here, I get a negative value, but with 3, I get a positive value. With t plus 1, we always get positive value for 1 and 3. And when you times this, then we get the velocity function. And here we get negative value, and multiplying 2 positive is positive. Do you see that? So we have the sign. Perfect. So let me rewrite the sign here. So we're saying that the sign, summary of sign, is right here. That between in the interval from 0 to 2, we have negative, and from 2 to 4, we have positive sign. Make sense? Even otherwise, to make it very simple for you, you could think like this. This is a parabola which is opening upwards, kind of like this, right? Where we are only considering the domain from this interval, right? So from 0, right, to a value which in this case is 4, right? So at 4 it is positive. Let's say this point is 4. Is that clear to you? And then, okay, let's not take that as 4. 4 will be slightly ahead. But here is 2 for us. Is that clear to you? So after 2 it is positive, and before 2 it is negative. Makes sense? So these are different ways of representing this information and understanding. But as far as the sign diagram is concerned, we did all the work here, and that becomes the sign diagram for us. Perfect. Now, what is the interpretation of velocity being positive or negative? So this really means that the object is moving towards the left side from 0 to 2 seconds, and then it goes like this. Do you understand? So that is how the movement is. So we have a state where this is t equals to 0, this is t equals to 2, right? So at t equals to 2, we have a turning point and moves towards the right side, which we consider as positive. Is this part clear to you? I'm taking too much of time here only to make this part clear so that you understand. And that is the reason why you have come here to watch a video, right? Most of my students do not understand this Y sign diagram. And now we'll see how it is going to be applied to find distance. So let's move forward. So what we figured out here is that when we have drawn the sign diagram, the object at t equals to 0, let's say t equals to 0, is moving left, and then it moves right. And this happens at t equals to 2, that it starts moving on the right hand side. Initially, it is going left. Okay, part B, determine displacement function s of t, write its units. So do not forget to include units. What is displacement? Displacement is integral of velocity function, right? With respect to time. So we are given the velocity function as t squared minus t minus 2 with respect to time. And that gives you the integral of t square with respect to t will be 1/3 of t cubed, right? Minus half of t square minus 2t plus a constant c. So here also try to include the constant c, right? So that becomes the displacement. So let me rewrite this function, which is s of t is equal to 1/3 of t cubed minus half of t squared minus 2t, and the unit being centimeter, right? So centimeter per second is multiplied by time, so that seconds cancel. So that is the function. Now in part C, we'll try to evaluate the values at different times. So once again, the displacement function s of t was the integral of the velocity function, right? So we'll do 1/3 of t cubed, simple, minus half of t squared minus 2t plus c, right? As you can see here, I missed c. So you have to include that. So you have to add c here. Now let's find the values at 0, 1, 2, and 3. So s of 0 will be only c, correct? All the units are in centimeters, right? Okay. Now what is s of 1? When t is 1, I get 1/3 of 1 minus half minus 2 plus c, correct? So that gives me, it's good to have a common denominator of 6 here. And as you get 1 times 2 will make common denominator 6 minus 3 minus 12, right? Plus c. And that gives you minus 13 over 6. So 2 minus c is minus 1, so we get minus 13 over 6 plus c centimeters. S of 2 is going to be 1/3. When you substitute 2 here for t cubed, you get 8, right? Minus half of 4 minus 2 of 2 plus c, which is, now in this case, we can take 3 as our common denominator, right? So we have 8 minus, well, that is 2. That is why I took 8. So when you multiply, you get 2 here. So 3 times 2 will be 6, and minus 2 is 4. 4 times 3 is 12. So that gives you minus 10 over 3 plus c in centimeters. Is that clear to you? So we got the value of s of 0, 1, and 2. Now let's calculate for 3, which is, let me change the ink here, 1 over 3. 3 cubed is 27 minus half, 3 square is 9, and minus 2 times 3 plus c, which is 9 minus 9 by 2 minus 6. Well, you can take 2 as a common denominator here. So we get 18 minus 9 minus 12 plus c, and that gives you 18 minus 12 is 6, or you can say 18 minus 9 is 9, 9 minus 12 is minus 3, so we get minus 3 by 2 plus c centimeters. Is that clear to you? So we have calculated displacement at each value of time, 0, 1, 2, and 3. Is that clear? Now the last part here is to find the total distance traveled in the first 3 seconds. Now this is where the sign chart will come handy. So we need to find distance when t is from, or let's write like this. First 3 seconds means 0 to 3, correct? From the sign chart, we understand that the particle initially goes towards the left, right? And then goes like this. So we need to find the displacement at each and every point, correct? So the critical values for us are what? Let me make it bigger. So the particle starts from here, goes left, and then comes and goes this side. This is how it is. We will now put the values of displacement here. So at t equals to 0, displacement s is how much? So when we substituted the value, we got the value of c, right? At t equals to 2, which is the turning point, we'll take the value. So at t equals to 2, we have a value here, which is minus 10 over 3 plus c, correct? So minus 10 over 3 plus c is the value of displacement s of 2 minus 10 over 3 plus c, correct? Now, we are interested only up to going to 3. So at 3, let us check the value. It was minus 3 by 2 plus c, right? Still negative. So it's minus 3 by 2 plus c, right? So this is at t equals to 3. So you have to check the distances from 0 to, you can say 2, right? Absolute value of that, add it to the distance from 2 to 3. That makes sense. Absolute value. So you get the difference of these two, which is absolute value of minus 10 over 3 plus c minus c, right? Plus absolute value of minus 3 by 2 plus c minus. So I'm writing in brackets minus 10 over 3 plus c. Is that perfect, right? So you can calculate. C and c gets cancelled, as you can see. So here we have minus 10 over 3 becomes plus 10 over 3, absolute value, right? C and c cancel. We have to add to this the absolute value of minus 3 by 2 plus 10 by 3, correct? Which is 10 by 3, and now this is add. So we can take a common denominator of 6. So we get minus 9, and here we get 20, plus 20. So we get this as equal to 10 over 3 plus 20 minus 9 is 11. So we get 11 over 6, right? So we have to add these values to get our answer, and we say distance. Let me write down in different ink. Distance is, add them up, taking 6 as the common denominator, 20 plus 11, which is 31 over 6 centimeters. Correct? 6 times 5 is 30. 5 1/6 of a centimeter. Is that clear to you? So that is how we are going to find the distance at the absolute values. So I hope this is absolutely clear. Perfect. Feel free to write your comments, share your views. And if you like and subscribe to my videos, that'd be great. So with that, we have solved the question directly. And you've seen the 4 distances we add absolute values. So very important to understand that to calculate the total distance traveled, we add the absolute value of displacements and get the result. I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.